Okay, you were live.
Okay, perfect. Well, everyone, thanks for joining this great session today. And I'm John Carpenter. I run the Hyperledger Denver meetup group, and we're doing this as a network meeting today. And we have a great set of guests with us today. And we're going to be talking about accelerating the path to production with Fabric Topologies. And we've got Taylor Trott and Alex Olaru. And I'll tell you a little bit about their backgrounds, but they're really experts in Fabric Topologies. Alex spent the first half of his career architecting and building mission-critical systems for trading, settlement, and risk management of derivatives at one of the largest options and futures clearinghouses. And then Taylor has worked in the financial software industry to develop cloud services for security modeling, management, and accounting. And we're going to have both of them go through with a very nice interactive presentation today. And if possible, we're also going to look at doing a poll via Zoom today. And you can kind of weigh in, and we want this to be very active. So the main thing what I'll say to you is, as we move through their presentation today, please feel free to use the chat to post any questions that you have. And as we can get them in, right with the presentation, we'll do that. And then definitely at the end of their presentation, we're going to go in and do a nice Q&A as well. So at this point, I'm going to turn it over to Taylor. And Taylor, why don't you walk us through this great presentation?
Thanks, John. Yeah, let me share my screen here. Okay, and just let me know if everybody can see this.
Yep, looks good. Yep.
Okay, great. All right, well, thanks everyone for joining. This presentation is going to be about Hyperledger Fabric Topologies, experimenting with and testing Fabric features. To give you a little bit of overview about the whole presentation, the first part will be just a little bit of summary about Alphaledger and its history with Hyperledger projects. And then we'll go into why we built these topologies. And after that, we'll look at the repository, go into a little bit of details about how it's structured. And then after that, we'll go through each of the topologies and give a little bit of a explanation and just a little bit of some details about each one. Let me just move this slide away a little bit here. So about Alphaledger, Alphaledger is developing blockchain-based infrastructure for the fixed income market to originate bonds. We both do loans and securities. Alphaledger was founded in 2019 with a mission to bring transparency, traceability, and increased access to the bond market. When we started with Hyperledger Fabric, it was with AWS, running in AWS with their ECS service. We have a smaller team, so as we worked with that, we found that there was this other service called AWS Managed. We switched over to use this for a period of time. That was good for smaller teams. That they manage a lot of the services. If you've used it before, that was all in TypeScript, compiled to the Node.js chain code. And so we ended up getting better resources, Alex in particular. So we were able to host our own version, and so we've been transitioning to be fully self-managed with the latest versions. And so some of the current things we're working on is adding external organizations that are external nodes that are running with external nodes that are parts of organizations running on cloud providers that are not our own, or even in accounts that we don't own. Okay, so why do we decide to build these Fabric topologies? So the first reason, we're trying to come up with a production-ready system, and so we wanted to address some important points. One of those is secure communication between the nodes in the network. Part of SOC 2 in the finance industry, they require encryption at rest and encryption over transit. So we had to make sure that that was supported, and we had to also look at load balancing and failover to ensure that, I guess basically the five nines of uptime, and that's one of the goals we have in trying to achieve. So we need multiple peers running and orderers, and what happens if they fail, stuff like that. And we wanted to also understand how the world state data changes between different organizations. And we also wanted to leverage the newer features of Fabric just to be able to say, hey, okay, Fabric released a new feature. How do we go about integrating that? Or even just what does this new feature do? And so those are the main points for production readiness. And so after the other point is there was lots of online tutorials and there's lots of documentation. I think one of the main things is that lots of these are sort of scattered and they're on different operating systems. Sometimes the blog will be using Mac, and sometimes Windows, and sometimes Linux. So we decided all these documents, let's just put them together into a single sort of Docker compose project. And let's see, and that was one of the reasons. And so we also wanted to, for the third point, we wanted to have working examples that were just easy to set up and experiment with. So I'll hand this slide over to Alex. Oh, Alex, I think you're on mute.
Sorry, can you hear me now?
Yeah.
Cool. And you can see my desktop, correct?
Correct.
All right. So in terms of the repository for the Fabric Topologies, so we're going to go over a little bit its organization and talk about basically how the topologies are organized and what are the main components for it, and what would you need to use in terms of starting up a network and tearing it down, and also some of the basic configurations or the most important configurations associated with it. So if we were to navigate to the, this is the same code base that you would find in the GitHub repository. I will navigate to that in a few minutes too. So we have at the top, we have a topologies folder, and we're saying that that each of the topologies is basically self-contained. What that really means is that everything needed for running a topology is located in that topology folder. The only exception to that are some very basic or common components that we use across all topologies. Namely, as part of Docker Compose, we have a network that is configured with a different name for each topology. So that's kind of the first Docker Compose base file. Then we have a shell command, which basically it's a service that actually is used across all topologies. And what this does, any commands that we need to run for executing, let's say, committing some chain code or invoking some chain code, registering users or things of that nature, even those run inside a Docker container. So nothing runs on the host, if you will. Everything is Docker based. So the two prerequisites for running a topology, any of the topologies, is to have Docker and Docker Compose installed. Now, inside of a topology folder, what you have two basic scripts: a setup script and a teardown. The setup basically has all the commands necessary to bring up bring up the network. In fact, you would see right now that I just brought up one of the networks, so topology number 4. It just came up. We're going to go a little bit more to see kind of what it means, but in essence, if a topology has started up, you would see at the end that it completed. You would get a message of this nature, and it also shows that it also shows at the end the fact that we have loaded a that we did a get command, an invoke command to read the assets from the network. So let me just really quick start up another one while we're going next to the slides. So as I mentioned, there's no need for any type of parameters to be passed along. Just do a startup, and then this will start again the network. The network is basically composed of the network itself, all the nodes, orderers, peers, fabric CAs, and things of that nature, but also deployment of a code, deployment of a chain code, and then the execution of the chain code at the end. Because in essence, we want to make sure that the network is running fine, and that's why we deploy and execute chain code at the end. So what we saw there at the very end was an invoke command to do a read of what the chain code wrote to the network. All the setup of the network basically has one single channel that all peers are joining for the different organizations. And there is one topology in which orderers are also joining the same channel. We're going to get to that last topology at the end. That's the topology that uses the system participation and the channel participation API. So just to come back a little bit to some of the other configurations. So the setup, again, runs all the scripts necessary to set up the network. The teardown will basically take everything down for that topology. The only thing that is going to remain on your machine is the image that got pulled into the Docker, in your Docker repository. And the reason for that is we want to allow it to kind of start up more easily. So the only thing you would really need to clean up that the teardown doesn't do are the images inside Docker. Crypto material for all the components in the network are created in this crypto material folder. So you can kind of walk through it, and then you will see for each of the components, the MSP folder with the certificates, the keys, and things of that nature, and the CA certs as well. So that's where you would find those. In terms of Fabric binaries, we mentioned that we can run multiple topologies at the same time. And those topologies can even run with different Fabric binaries. The way that's achieved is through this env file, this configuration file, where for each topology, you can go and actually adjust the Fabric version that you want to run for each of these components. Obviously, the topology will use a certain features, for example, channel participation. You will need to make sure, a newer feature, you would need to make sure that the version that you're using actually supports that feature. But other than that, this is the place where you can make changes. In terms of ports, this is an important one. So when we run inside of a script, just to come back really quick, when you see a Docker compose, it's actually kind of layering three different Docker compose files. It's this base one that we mentioned at the end, and then the one for the shell command. And then there is the Docker compose that it's set up in each single topology. And then inside it, what you'll find here that the ports are pretty much all commented out. So what that means is that no ports of the containers that are running are actually exposed externally to the host by default. The reason for that is kind of twofold. One, we didn't want to conflict with any ports that might actually be already be taken on the machine. We wanted to make sure that the network starts up without problems or without any issues, due to this power conflict. And secondly, if you want to have actually multiple networks running concurrently, it gets a little bit trickier because then each topology would have to have its own port, for example, for a CA and things of that nature. So we left it here for the users to make adjustments as they see fit, and just open the ports that they need for certain components just at the startup time and when they start up a network. In fact, we'll see, I'll actually just show two examples right now because they're going to come up when we're going to be doing some testing. So in this case, I open a port for Postgres because one of the topologies we're going to review later deals with storing data for the Fabric CA in Postgres. So we want to be able to browse some data in Postgres. So therefore, we open that port. And later on, for example, here for CouchDB, for OpenLDAP. For OpenLDAP, we're using that to also in one of the topologies. We want to be able to access that OpenLDAP server, and therefore we expose the port to the host. Let me see what else then we can cover here. So there is a lot of repetition actually in terms of what the setup scripts does if you were to look from one topology to another. So the setup script, for example, for T3 to T1 would be looking very similar with just a few changes, right? And the reason we didn't want to move this kind of common things to like higher level common components was because we wanted to allow for comparison between topologies. So in this case, what I'm looking here, it's a comparison between topology T1 and topology T3. So T1 is the base one that Taylor has been talking about. T3, I think, is the one that deals with his external chain code. So this is making it easy now because we can actually find out, okay, what were the new files, the new configurations we had to set up, or what did we need to change, for example, in a YML file, right, for Docker Compose. Oops, I closed it. I'm going to open it up again. Or a script, right, like I mentioned, the setup script. What is it different between T1 versus T3? So we think that makes the understanding of changes that they have to be made, because there's in some instances there's quite a few changes. It makes it easier to understand the differences between topologies. So I think we covered all the basic things at the moment. So as you can see here now, really quick, in Docker desktop, I have actually, if we scroll down, just a second, I have this in front of me. If we scroll down and look at the, sorry, I wanted to look at the containers. So for the containers, we have basically here topology T4, right? And then at the same time, we have a topology for T5 running concurrently. So that's what makes it easy to have basically multiple networks running at the same time. With this, I'm going to turn it over back to Taylor to start walking through the first topology, or first set of topologies to kind of explain what's happening inside each one of those.
Okay, thanks, Alex. Yeah, that was very helpful. Thank you. Okay.
Yep.
Okay, how's the screen showing up?
Yep, the screen looks great, Taylor.
Awesome. Thank you. Thanks, John. So the first topology we'll start with is T1. It's considered the base topology. We use this topology to form like the root, the base point for all the other topologies. So sort of going through these diagrams you're going to see on each of the slides. We have these green boxes representing each organization. Within each organization, you're going to see various blue boxes, which represent the different services running. So for example, org 1, we have an orderer's service running, we have a certificate authority service running. Org 2, we have peers, certificate authorities. Org 3, we have peers, certificate authorities. And so within the blue boxes, we have like individual, I would call them like nodes, maybe, so you have individual services. And also, you can see they give you each maybe has a little more detail, like on this peer, you can see it says level DB, internal chain code. And then you can see right here, it says peer 1 CLI. So it's quite detailed in each one of these diagrams. And under the certificate authorities box, inside the box, you can see that there's 2 gray boxes, and the first one says Fabric CA TLS, and the second one says Fabric CA identities. The Fabric TLS is responsible for issuing the certs for the communication, secure communications between the orgs and the member nodes. And the Fabric CA identity service is for the issuing the certificates to for the endorsements of chain code and such. So this is this is T1, and so we'll look next at T0. So T0 is sort of T1 minus of 1, so it's minus org 3. We've reduced the number of orgs, we've reduced the number of orderers and peers, and we just we did this mostly just to have a very even more simplistic network to start up. And so let me just go to the next one here. So this is more interesting here. So T2, we have additional orderers and peers. So we've taken and we also have some other improvements, or I'll get to that. But we have additional orderers included under the other org 2. And on top of that, we've also added Nginx proxies. So as you can see, we have orderers in org 1 and org 2. And so when you want to reference the order in the chain code, for example, it would make sense to have a proxy versus having to determine which orderers to send the transactions to endorse. Let's see. So there's also peers. This one includes an orderer's proxy and a peer's proxy. So both the orderers and peers in this topology are being proxied. And just to show you a little bit what that looks like, we can go into the code files here. Let's exit this. So in Meld, I have, I think we're on, sorry, was it T2? Yeah, T2. So rather than use Meld, I wanted to show you the Nginx proxies here. So we'll go to T2, go to the configuration, and you can see right here, there's an orderers proxies and peers proxies. So there's proxies. And for example, here's the orderers proxy configuration for Nginx. So we have it configured so that it's like a pass through, and it's using like SSL. So it's secure, and it's just passing the communication to the whichever orderer we have configured here. And we also do the same thing for the peers. Each org has a proxy for their peers. Oh, and also the peer, if you want to know on this topology how the Nginx servers are configured, that's under containers, orderers. Here's the orderer proxy container here. So you can see this is where the Docker image is being configured here. So let's go back to here. Okay. So looking at the next topology T3, this is a T1 topology plus an external chain code server. As you may have remembered, in the T1, all the chain codes were installed internally, so internal chain code. And then this topology, each of the orgs that have peers, we've installed the chain code and external chain code container service. So let's look at that real quick. But I can show you right here. Well, the only difference on this graph is you can see in this box, we have the external chain code right here in orange on each of the org2 and org3 peers, and the peers no longer have internal chain code. And this one I have up in Meld to look at real quick. So we have just an example of how using Meld. We're looking at T1 to T3. So we want to know, okay, what does external chain code require? Well, we can see that there's a build pack. Let's see, there's some modification to the chain code. There's some configurations that you have to add for each organization that has the external service. There is a core YAML file that needs to be updated to point. So this, if I go into this file, you basically have to point to this build pack and say that you're using the external build pack. And then we have the external chain code Docker container definitions here. We've modified the peer configuration a little bit, and some of the scripts have changed. So there's a lot of, probably I would say, slight differences in how the chain code gets installed there. Let me just make sure I got everything here. Yeah, I think that's what I want to say for T3. Okay, so let me hand it over to Alex for T4.
Start sharing again. All right, so T4. This one deals with the configuration on LDAP store. So if you happen to have worked with Fabric CA, you know that there, as Taylor mentioned, there are two types of sets of crypto materials that are being created, right? Some for SSL communication, but the others for identities for each of the nodes in the network. Now, those identities in the network, when you register them in Fabric CA, you provide a user ID and a password. And we'll see later that ends up being stored in a database that Fabric CA works with. And that's okay for good number of environments, but in some places, like larger enterprises, security departments, InfoSecs, they kind of want to use the kind of single store, the enterprise store for users, principals, service accounts and things of that nature. And that typically tends to be an LDAP compliant store. Probably the most popular of those is Microsoft Active Directory. Now, there is some support with Fabric CA, whereby instead of having to register with these identities with Fabric CA, you can actually kind of hydrate it or seed them, if you will, from an LDAP store. So you can actually configure then the Fabric CA to work and connect to an LDAP store. So what we wanted to do here is basically see how that works with an LDAP compliant store. To make it easy here for deployments, we've chose to use Open LDAP, which is an LDAP compliant store. We're going to look at with a tool, a browsing tool, to an LDAP browser to kind of see what data gets stored in Open LDAP. So I'm going to go over some of the key configurations just so you can kind of have a sense of this. So if you start up that topology, T4, you will get, as part of the setup, a container for Open LDAP, and that container will be configured to load at startup time organizational units from this LDIF file, and then also counts that sit under those organizational units, right? So this is the base domain, the domain controller, and we will take a look, in a second how that how looking inside Open LDAP. When the Fabric CA is configured, there is an LDAP configuration. If you looked at the Fabric server configuration, there is a section for turning on LDAP. So if you turn on LDAP, then you can have it connect to a open LDAP repository or LDAP compliant repository. So again, in this case, we basically have a container, right, exposing on that port. That's the base domain. And then what you see, this long string, is basically a user, right, to connect. It's like a bind user, if you will, is the user and the password to connect to that store. So if we look with JExplorer, this is basically for org1. We have kind of two OUs, right, organizational units, one for identities, the other one for TLS. Identities probably is the more important one. And then here you would see the users that we've kind of loaded from their LDAP file, right? So we don't have a Microsoft Azure or an Azure directory right here. So we're just kind of mimicking something, to just kind of prove out the concept. Obviously, once you have it work with something like this, it's not that difficult to actually make a change and connect to an Active Directory. And in this case, right, you would probably have to adjust the user filter. Like if it's open LDAP, UID is typically the unique identifier for a filter. If you were to go, there's like an SM account name, for example, Microsoft Active Directory. So there might be some queries, right, that have to be adjusted here, some configurations. And if you work with your Active Directory administrations, they'd be able to help you with that. But the point is here, we can see that Fabric CA can indeed, connect to these repositories, and instead of again having to register accounts, the users and the passwords actually come from Active Directory, right? So that actually can save quite a bit of configurations, and then it can make the deployments, kind of more enterprise ready. So that's on the LDAP configurations. If we go next to T5, staying with Fabric CAs, sorry, I forgot to show here, but basically this is the open LDAP, right, that kind of supports both of these organizations. If we were to go now and look at Fabric CA clustering, so Fabric CA, I mentioned it has a database, a relational database to store state, user certificates and things of that nature. That database is SQLite. It can actually be configured though with Postgres and I think MySQL as well. Now, why would we want to do that? Is it just in case if we want to provide failover for a Fabric CA component, right? We can actually have now two nodes for Fabric CA working with the same set of users and credentials and using Postgres behind the scenes to store their data. That's not possible with SQLite, right? With Postgres, you can also, use a cloud service, or you're not limited to SQLite. You can almost view it like an embedded database, right? Not very enterprise scale. So what we have here, we have a Postgres server with two databases in it, one that supports TLS, the other one that supports the identities. So I showed earlier, right, like how we expose the port for that T5, I think, right? So we're exposing this 5434 in Postgres. And then if we go with the query tool, we basically can see here that we have two databases, a Fabric CA TLS and identities. We kind of like to get a sense of what's inside, this. So you can actually go and see that there is users, right? There's a user table, and there are users set up inside it. And then there's also certificates. So this is where the certificates actually get stored. So when you do an enroll command, right, and you have a certificate issued for an identity or a certificate for well, an enrolled, yes, or you have certificates issued for SSL. They get kind of sent back as a result, but they actually get stored in the database as well, because then they can kind of be organized under a particular CA. So that's kind of the data store that goes behind these Fabric CA servers. And I think that's kind of the main point here on this again, show, running example of how this can be set up. Moving on to T6, mutual TLS. So by default, all the topologies have SSL enabled. However, if you were to, for example, have a network where you have nodes communicating over the public internet, and there is no point-to-point like a VPN connection, in that scenario, and probably many other scenarios too, it's very recommended that you actually have nodes authenticate to each other through client authentications, right? So that's what kind of mutual TLS means, client authentication, SSL or two-way SSL, however you want to call it. So what we've done with this one, we basically enable client authentication across all the different components. So if I was to go here and show inside T6, just some examples. So if you were to look at scripts, again, you could see this with the diff to T1. So for example, when we commit chain code, you see this parameter client auth, right? So you wouldn't see that in T1 because we don't use client authentication. But what it means here is that this administrator account, when it invokes this command, it connects, right, to peers and orders and so forth. It authenticates itself. And the way it authenticates itself is with this parameter. And then it has a certificate and a key file and certificate. The certificate gets sent, during the SSL handshake, gets sent to the server, and the server then can verify that it's signed, the certificate, it's signed by a known certificate authority to that server. And so this way, we can make sure that only nodes or only entities that are allowed to connect to those components inside the network, can actually do work with them. Yeah. So again, very important for secure communications across internet. In fact, even like 2.4, I think some of the commands in 2.4 actually require client auth by default. So it's a good thing to learn about anyway. T7, private data collections. This basically deals with storing data off of the public channel. So data that is maybe private to a certain org or a set of organizations. So what this does, it basically configures some private data collections, and there is some data that gets stored in this private data collection. So if we were to look again at configurations, let's say when we approve some chain code, one organization approves its chain code. Sorry, we have to go to T7. So in T7, if I was to look, again, these scripts, I forgot to mention this, all these scripts get called from the main setup, right? So that's kind of, but we just wanted to have it a little bit more modularized, if you will. So that's why we have them separately here. So in the approve, you can see that there is a collections config, right, that gets passed to the approve. If I'm not mistaken, this is the collections config. So you can see this is how you define a PDC, private data collection. In this case, it's a PDC that only this member has access to read and write. And then you could see then in the chain code, again, this is the basic chain code that we have from that is part of the distribution, the Fabric distribution. So here we basically store the assets, if you will, on the main channel, but we also put data into the private data collection. So we put for example, in this case, I guess we're putting also the same thing, the asset, but we're putting in the private data collection, right? So there's a put for private data. Yeah, so that's how we leverage the private data collection. All right, so let's go next to T8. So the T8, it's a cluster CouchDB configuration. We think this is probably one of the most important ones. As you know, state in Hyperledger Fabric is represented by two types of data storages, if you will. So you have things like the blocks themselves, right? They kind of get stored with the orders, and then can be pulled with the peers and so forth. So that's kind of the chain, right, of changes that happen over time. But then you have the world state. So the world state represents what's the current state of any record that you stored on the blockchain network. By default, the database used for storing that state is called LevelDB, and I kind of view it again as more like an embedded database. Works fine, if you just want to stand up something and run fast. Apparently, they're even like maybe a little bit faster from a performance standpoint of view than CouchDB. But again, we like to look at what's the data inside, that we can store, maybe balance some numbers, maybe, do a query or two. Not very fancy in terms of analytics or queries, but just kind of get a sense of, what do we have as far as data in the blockchain, right? Because otherwise everything can just kind of seem like a black box, and it's, hard to show a user, what's inside a blockchain. So for our deployments, we use heavily CouchDB, and we externalize CouchDB. It runs its own container. I mean, when you talk about Kubernetes and things of that nature, I mean, it's very nice because then you can have dedicated storage, different IOPS. I mean, you can treat it more like a, enterprise database if you use CouchDB as an external database. So in this case, for Peer 1, we're using CouchDB instances, and we actually have two of them. We have a clustering setup for them, so that's actually quite useful if you want to see how. I mean, there's manuals, of course, in CouchDB on how to set up CouchDB, but this is a working example of a cluster, and then it's accessed by Peer 1 through this CouchDB proxy, right? So what's nice about it, then yes, when you have it set up, you can actually go. So we have this T8. Let's see, I started up T8 earlier, here. Actually, let me just show really quick. Right, so this is the T8 topology. I mentioned here that, at the end we do, this was the get all assets, right? That's what we were seeing at the end, that we got all the assets. Okay, here they are. And now if I want to see them in the database, CouchDB, we have two nodes. Yeah, if you remember the ports again. Actually, no, this one, actually we left by default the CouchDB. It's the only one that, even if you look in the repository, it's actually the only one that has external ports already mapped. So this one's here, right? So 5987, 5988, 5987. So if you log into it, the user ID and password are in the configurations. Again, it's a little bit interesting, at least to figure out how this gets stored. So this, typically the way things get stored, there is a channel name, and then there is the chain code name. So then you can navigate inside, and you can actually see all those documents that we've put. You can add the indexes through this. You can do management, right? You can add views. So there's a few things that, I mean, it's not nowhere close to like a relational database, but there are some things that can be done in terms of performance tuning and configurations for CouchDB. And of course, this is just the same view, but from the second node. And then if you were to go to like config, you can see here, right? It says that it seems that you're running a cluster with 2 nodes. So for this kind of settings, they don't let you to do configurations through the UI, and then you kind of have to do them through the configuration files. So again, we think probably this is one of the most important ones in our view, as far as, from all of this, I guess I will look at the mutual TLS, and these ones are probably the ones that are most important, we think, for enterprise deployments. And then going to the next one and the last, this is the channel participation API. Again, a newer version. I think it's 2.4 that it got fully implemented. In this configuration, what's nice about it, there is no more need for a system channel. So prior versions, right, you had to have a system channel set up first, that all orders have to join to. Additional configuration, impacts performance, so a bunch of things that are not very useful maybe. So it's very nice that the team at Fabric came up with this approach of channel participation API, which means that just the way a peer joins a channel, orders do the same, right? So you can have an orderer joining 2 different channels, right? And it just becomes a lot more scalable and in many ways, easier to configure. So the way you would see that, what we have here is, go back. So we have in org1, we have 3 orderers. So if we go to the org1 scripts for joining channels, because you might wonder, right, org1 has no peers, what are we joining? Well, it's orderers now that are being joined. So this is a newer command, right? OSN admin, order service node admin. And as you can see here, we're joining the same channel that the peers would join. Again, a working example of how channel participation can be set up. With this said, I think we have 10 more minutes. Maybe we have questions, Q&A. I'll turn it over back to Taylor and John. Maybe we run the poll as well. So I'll let them share, and then we can also answer if any questions come from the audience.
Yeah, no, that's great, Alex. I think at this time, it would probably be best to run the polls first, and then let's take Q&A after the polls. So David, I don't know if you have those available ready to go, but if you do, let's go ahead and do that. Otherwise, we'll cut over to the Q&A.
Okay, I just launched the poll. We'll give people a minute or 2.
If you want, I can share. I can continue to share, and then for anyone that might not have access to the poll or has difficulty with it, I guess we'll just pop up here the questions as well, and people can answer in the chat if they wish to do so.
Yeah, is the poll showing up for people?
Yeah, it's showing up on my screen, David, and I can
Great.
see.
Great.
I don't see any votes coming through yet. Looks like we haven't had any. We have 1 person that's voted now in the poll. 2 have gone through and voted.
Yeah, and if people would rather leave comments in Zoom chat or just share their comments on voice, that's fine, certainly.
Yep. Now we're getting some good responses. We got 7 people have already voted in the poll.
Cool. I'll flip in a second to the next question on the slide.
Yeah, no, that's perfect. Okay, we've had 9 people that so far have participated in the poll. Okay, I'd say let's just give it another, few minutes here for people to go through. It seems like people are still voting.
Sure. Yeah, and if we want to do some Q&A while people are voting, feel free. I see some questions in Zoom chat.
Cool. I can actually, Taylor, let's look at those and try to answer them.
Yeah, and if you just want to kind of read them out and then respond to them, that'd be the best way to do the chat Q&A.
Yeah, Alex, so the first one I saw that is from Ramesh. It says, how about the TLS certs? External CA is allowed or only self-signed CA is generated?
So in the topologies, everything well, I wouldn't say necessarily self-signed because the certificates are signed by the CA certificate that comes with Fabric CA. So, but the Fabric CA self-signs its own certificate, and then it uses that CA certificate to sign the certificates for the identities, for example, right? Now, to plug in a external one, I mean, that is possible as well. But in that case, you would have to deploy inside of the crypto material folder. You would have to deploy your own certificates.
Yeah,
Okay.
that makes sense. And then we have another one from Drago. It says, if the Fabric CA is used, would it still be necessary to have a middleware to authenticate?
A middleware to authenticate. Well, what happens, Dragos, I mean, when you mean authenticate, like nodes authenticated to each other, or like an admin account authenticating to a node? Because I guess I could explain. I mean, there is no user ID.
Nodes off to each other.
Nodes off to each other. Okay. So in that case, basically there is no like user ID password authentication happening at that point. Everything gets done through certificates. So that's where you would use that client authentication. So you enroll, you get the certificates, and then using those certificates, then the nodes authenticate with each other, right? By the way, I should mention that when Open LDAP is used, or an LDAP compliant store is used to hold identities, that skips the need for having to register identities, but you still need to do enrollments in order to issue certificates, to use for communication, and to have your MSP folders populated with them. Again, this is just one approach. I know the Fabric team actually is looking at kind of other maybe Kubernetes-based mechanisms to generate certificates. So Fabric CA is not the only one way you can generate certificates, right? So I want to make that clear. But it's just a way that comes by default, and it's a pretty decent way to get started with.
And it looks like there's a few questions on this one. It's about supporting multiple host deployments.
Multiple host deployments for which components do we know?
It looks like sort of a full decentralization. Maybe there's different machines running with different IPs.
Yeah, I mean, that's so, yeah, I mean, that's what we do, in our case, right? I mean, we have, we're actually trying to set up across, multiple cloud providers, network, I mean, components talking to each other. The purpose of the topologies is to allow you to allow users to understand, how these nodes communicate with each other and where configurations have to be made. But yeah, it's certainly possible when you do your initial, for example, when you create the initial channel, right? And then you have to specify orderers. So those orderers can have their own domains, living, those nodes can be in different networks, right? And they can talk to each other over the internet.
Okay, and we have a question from Satish. I'm not sure I quite understand it. So are there any specific advantages of having orders and peers deploy in a Dockerless fashion?
Dockerless, without Docker. I mean, even like with Kubernetes, right? Still, you could say you still kind of need some Docker, right? Configurations. It's not that kind of means, you can handle it with Ansible, Chef, right? You can do the setup. You can run them on bare metal. There's no need, it's not a requirement to have Docker. I don't really see the advantage. I mean, I guess it depends at the end of the day what tools you're familiar with in terms of automation, because that's the biggest thing here, right? I mean, to really get these networks to work, to have large scale deployments, you really need to have automation infrastructure as code. I think there are actually a couple of projects like, you haven't looked at the Hyperledger Fabric operator. That's a big one, that's kind of coming up to, it's focused on getting Fabric networks deployed with Fabric operator basically in Kubernetes environments. But if you're familiar with Chef and Ansible and you want to do it in bare metal, and there's no problem with doing that.
I think maybe two more questions we have. We have one question about, is there a structured query language encryption solution? And then, are there any production networks currently running with these topologies?
So I don't know about like a SQL for encryption that I'm aware of. So I thought it was more meant, how we query, CouchDB. So CouchDB has its own DSL for data query, but as far as encryption, I'm not sure, what solutions would there be that are SQL based for that. And in terms of the topologies, you can see what we have here. I mean, if okay, let's put it this way: we're not aware of someone using, this in production, and it's not really meant to be used directly in production. It's meant again to help people understand how these configurations work through working examples, right? And then from there, take those learnings and deploy as they see fit into their production settings. But again, it's important in our view to look at some of these features that Fabric comes with. Again, we talked mutual TLS, data storage and things of that nature. We think it's, those have to be understood well in order to leverage Fabric at its full capacity. Any other questions or? Okay, well, thank you so much. I mean, I think we, on this last slide, I don't know.
Yeah, maybe let's take a look at the poll, Alex, now that that's completed.
Do you have the results on your side? Would you like to share it?
And
Sorry.
Taylor, do you have those results? Or
I can share, yeah.
David can share those out with the group here.
Let me
Okay,
share my
perfect.
screen. Is that okay to share the screen? Or? So it looks like for number one, we have the adding an org incrementally. So that's a few other ones here.
Oh, you know what happens, Taylor? I think this is a Zoom, and Zoom itself.
Yeah, it is a Zoom one, yeah.
Oh,
so
it's not
David,
showing the
I don't know
polls?
if you can.
What you could do?
Zoom, yeah. I'm telling it to share the results. I think it's saying that it's sharing them on my end.
What you could do, Taylor? You could take a screenshot and then screenshot.
Yeah, unfortunately, Zoom doesn't share its own interface when screen sharing. Are people not seeing the poll results though? I told it to share the results.
I saw the results.
David, I can see it. Okay, Brett, can you see it?
Yeah, definitely.
Okay, good. So Taylor, if you want to kind of read off the overview, or if you need me to, I can do it as well.
I got it now. I can share my screen. I took some screenshots here. So that should do it. Let's see.
Perfect. And I
And
think
we're
this is
gonna
great
need to drop in a minute. I think another call has this room at the hour.
Okay, yeah, we should go ahead, just, if you got 2 minutes to take, Taylor, to just kind of run through those, great. Otherwise, we're gonna have to drop, as David says.
Or, yeah, or we can add them to also as a slide.
Can you see this, Alex, and everyone else?
Yeah, we can see.
You see it.
Yeah, but you might want to just kind of read through it. Yeah, that looks good.
All right,
Yeah,
so
and
yeah,
we should. We can share the results over email. Taylor, if you want to send that to me, I can share it out with everybody in the call. If we want to add it to the presentation, I'll send the new presentation out to everybody.
We can do so.
Great.
Yeah, we can let the room go. Thank you so much for everyone that participated.
Yeah, thank you, Alex. Thank you, Taylor.
thank you,
Thank
everyone.
you.
Yeah,
Really good presentation.
everyone have a wonderful day, and thanks for joining this great informative session.
Thank you so much. Bye.
Thanks, everyone. Bye-bye.